Hello everyone. So in this video I'd like to start a new topic that is actually the load flow analysis, and in that specifically Gauss seidel load flow. So before we go into this topic, let me present you one problem which I would call some kind of a challenge problem, which you can try yourself. So the problem is something like, in fact, it is two problems. So the first problem and second problem. First one is actually easy. It's not at all a challenge problem, and the second problem is actually a bit difficult problem. So what are these two problems, and then what do I exactly mean by why it is one is easy and the other is difficult? And once I present these problems to you, you can pause the video, you can try to solve it yourself, and then you will realize the easy problem you can solve it, but then the difficult problem is indeed difficult, and you need some kind of a mathematical tool to solve it. Okay, so let's look at the problem. So the problem is actually like this. So there is a generator. Assume that this is an ideal generator, and I am generating V1 at the angle of delta 1, and then there is a line whose reactance is J 0.1 per unit. So this is the impedance of the line, and then on the other side there's the another bus V2 and the angle is delta 2, and then at this bus a simple load is connected. Now I'll also mention the load in per unit. So I'll write S equal to 0.6 plus J 0.3 per unit. Now we have four variables here, V1 delta 1 and V2 delta 2. These are called four states of the system. So the state variables are all the voltage magnitudes and all the angles. So if there is a 5-bus system, you will have 10 state variables. And similarly, if there is a 7-bus system, you will have 14 state variables, because the voltage magnitude and voltage angle for each bus is called as a state variable. Now, out of this 14 state, so in general, if there is an n-bus system, it will have 2n state variables. So n-bus will have 2n state variables. Now, assume that, so this is the first question. So if first question is supposed to be easy one. So if V2 delta 2 equal to 1.0 angle 0 degrees per unit, find V1 delta 1. So this is the first question. And the second question is, if V1 delta 1 equal to 1.0 angle 0 degrees in per unit, find V2 delta 2. So this is the first question and this is the second question. And as I was saying, this is easy and this is difficult. So let's try to solve it. Let's take the first one. Obviously it is easy, so you can also like pause this video and then try to solve these two problems. Then you'll really understand, so this is where there is a purpose why we are studying a load flow problem, because load flow problem is not straightforward to solve it. We need some techniques. So one technique is Gauss seidel, there are other techniques. Let's come back to the first problem. Now I will simply generalize it. So let's denote this as x equal to, so this is x is the impedance of the line, and then s is the load at bus 2. So I have all the variables. So let me also denote the current flowing in the line as I. So or I12. So what is I12? I12 is the current flowing in this line, which is nothing but V1 minus V2. So of course this is a complex numbers divided by X. So the voltages divided by the impedance will be nothing but the current, which is also equal to, so what is the current here? So the same current will flow here, I12. So I have the complex power and then I have the voltage. So I can use the formula, that is complex power is nothing but voltage into current conjugate. So from this, current will be S by V and then current conjugate will be S by V. So from that, this implies that I'll get I is nothing but S by V, S conjugate by V conjugate. So this we have used, this we have done before also. So S conjugate divided by V2 conjugate. Now in this, if V2 is coming two times and V1 is coming only one time, so that is where the easy and difficult part will come into picture. So let's solve it, the first problem. So I don't know what is the value of V1. V2 value is 1, so minus 1. And what is the value of X? J 0.1. And what is the value of S conjugate? So S is 0.6 plus J 0.3. So 0.6 minus J 0.3. And then what is V2 conjugate? So 1 conjugate is 1 because the angle is 0 degrees. So it is just denominator is 1. So from this I can calculate V1 is nothing but, so 0.1, so this will J 0.1 multiplied by 0.6 minus J 0.3, and then this minus 1 will go to the other side, it will become plus 1. So I don't even require calculator right now. So I can just multiply these two. So J is 0.06 and then J into J is minus 1 and then already there is a minus. So it will become plus 0.03 and then again I have plus 1. So let me also once verify the direction of the current. Alright, so from this I'm getting 1.03 plus J 0.06. So if I want to express in terms of magnitude and angle, so let me switch to my calculator. So I have V1 equal to 1.03 plus 0.06 I. So I want absolute value of V1 and angle of V1. This angle will be in radians, so multiply by 180 and divide by pi will convert into degrees. Sorry, this is angle. So I'm getting 1.03 angle 3.33. Per unit. So this is V1. So I have solved. So V2 is given and then V1 I have solved it. So that's the easy part. Now let's come to the second question, that is why it is difficult. So now we look at this once again. So I come to the second question. So the problem here is I know what is V1, so that is 1. Then V2 is unknown, divided by X also we know, is equal to S conjugate, that is let me keep it as S conjugate, and then V2 conjugate. So in this equation there are V2 is on both sides, which is unknown. So of course S is also known. Now how do we solve this? So you can manipulate this in different ways and then finally you will get one equation. So but then if you try it out really, it will be not so easy to determine what is V2. So this is a complex equation and it is having two unknowns, V2 and delta 2, and you have this one equation and it's not straightforward to solve it, but it can be solved. I'm not saying it is impossible to solve. In fact, it is possible to solve this, but then there is neat and easy way to solve it, or proper way to solve it. So anyway, I'll just ask you to attempt this. So try solving this for V2. In fact, I'll just for the sake of completeness, I'll also replace this with the known number, that is So I know that this value is 0.6 minus j 0.3. By the way, why I'm putting minus here? Because of s conjugate. So this is equation with one unknown. Oh, you might get an idea. No, why not form it as a quadratic equation and solve it? You can say v2 minus v2 square, but then there is a conjugate. So v2 into v2 conjugate, all right, is equal to j point 0.1 into zero point 0.6 minus j point 0.3 and so on. So you can think of different ideas, but then the whole point is because v2 is a complex number, it will not be a straightforward to solve it. But then I challenge you to try solving this for v2. Okay, so let's let's now move forward and then see about you know one method called Gauss-Seidel method, which will be useful in this way. So a mathematical trick is needed to solve above equation. So first I'll explain the mathematical trick applied to general linear equations, and then we'll apply it to power system equations. A little bit of theory. So if you go to Wikipedia, you will find about Gauss-Seidel method, the theory and all. So let me get the name correct. John Carl Friedrich Gauss. This is one, and the another person is Philip Ludwig von Seidel, of course. So these are the two German mathematicians who invented or whatever who proposed GS method or Gauss-Seidel method in the year of 1823 AD. So almost 200 years old method. We'll try to apply it and then solve it. So we will learn the method now. So just take two unknowns and two equations. So for example, solve 10x minus 3y equal to 4, and then 4x plus 5y equal to 7. So if this was the question asked to you, how do we solve it using GS method, Gauss-Seidel method? So first what you do is from the first equation, find out what is x. So how do I find what is x? So x equal to 4 plus 3y divided by 10. So I think you will agree with this. So 10, just minus 3y will go to the other side, will become plus 3y, and will get divided by 10. So x equal to this one. Then from the second equation, find out what is y. So y equal to, what is that? 7 minus 4x divided by 5. That's it. So x is given and y is given. Now the thing is, in order to find x, you need y. In order to find y, you need x. So it is like that. So next step is initial solution. So let's say x0 is 1 and y0 is 2. Whatever, randomly. You can take minus 1 and 5 or 7 and 8 or whatever. This initial solution choice, of course, it has to be done in a proper way where you can reduce the number of calculations. But then for this small problem, it doesn't matter. You can take any values. So now I can apply these and find out. So first iteration, or iteration 1. So what you do is x1 equal to 4 plus 3 into y naught and divide by 10. So I'm using this equation. So y naught is 2. So that is nothing but 4 plus 3 into 2 and divide by 10. 3 into 2 is 6, 6 plus 4 is 10, and 10 by 10 is 1. Oh, luckily, whatever x I am taking, that itself is coming as the x. So it is like a trivial thing. So let's not do like that. Let's take initial value of y naught as, you realize I'm wantingly making it more complicated. So let's take it this as 1. So now 4 plus 3 into 1 divided by 10. 7 by 10. So I get the value of x1. Then this x1 will be substituted in the second equation. So y1 equal to 7 minus 4 into 7 by 10 whole divided by 5. So then I'll get some value of y1. Then I start the second iteration. Then I'll find out what is x2, y2. So from the old value of y1, and then this x2 I'll just use it here, and then I'll find the y2 value. Once I know x2, y2, then I say third iteration. I'll find x3, y3. Then I'll do fourth iteration. Then I'll find x4, y4, and so on. After some time, you realize that the difference between the last two values is not much. So you finally converge to a solution, and therefore, after some nth iteration, you will stop the process. So this is Gauss-Seidel method. So let me demonstrate it to you for the same example. So I have this. So on the left, I'll just write a simple program. So x equal to, let me start my initial solution, x equal to 1 and y equal to 1. This is my initial guess. Then what is x equal to? 4 plus 3y divided by 10. So this is my, let's call it as equation A, and this I'll call it as equation B. So 4 plus 3y divided by 10. 4 plus 3 into y divided by 10. So this is my equation A. And what is y equal to? 7 minus 4x divided by 5. So 7 minus 4 into x divided by 5. This is equation B. Now again I have to run equation A. So I want to repeat this. So simply I will write for m equal to 1 to 5. So let's say I want to run 5 iterations, and then I'll say end. So 5 times I am repeating. So this for loop. So x, using y I'll calculate x, using that x I calculate y, again using that latest y I'll calculate x, and so on and so forth. So here I'll just display the value of x and y, x, y. So let's run this program if there are no errors. So on the right hand side, you see we are getting this solution. So finally, what is the value you are getting is, you see the third decimal is 0 and 1 here. Here the third decimal also 1 and 0. So I think I'll do it for more iterations. Let's say 10 iterations. So now you see there is not much of difference between the 9th and 10th iterations. So my final solution is x is 0.66129 and y is 0.87097. So that way I'm able to solve the problem using the Gauss-Seidel method. It's an iterative method and you can solve it. So let me just copy this. Now, how many iterations are required depends on the problem size. So sometimes you require 5 iterations, sometimes 10 iterations, sometimes maybe 20 iterations or 30 iterations. It's a larger problem, but then eventually you will get the solution for some problems. Okay, so let me just make a note of this. So I'll just what happens if I change the initial guess? So let's say x equal to 20 I'm taking and y equal to -5 I'm taking. So some random numbers. So let's see how it behaves now. So again, I'm getting the same solution 0.66129 and 0.87906. So if I take y is -50, so again if I run it, so almost same value, but not exactly same value. So let's run it for more iterations. Instead of 10 iterations, I'll run it for 15 iterations. So again, I'm getting the same solution. X is 0.66129. So what you learn from this is by properly choosing the values of x and y, you can actually reduce the number of iterations and get the solution quickly for your problem. All right. So So I hope you got the idea about what is this Gauss-Seidel method. Given a set of equations, you write in terms of this. So, so one thing you notice here, if I write it in matrix form, so this is 10 minus 3, 4 and 5 multiplied by x, y is equal to 4, 7. So this is in the form of ax equal to b. And when you look at matrix A, the magnitude of diagonal is more than the any other element there. So 10 is the highest here. And similarly 5 is the highest in the other one. Now what happens if I flip the equations? So, so I'll take these two equations or I'll simply flip the equations. So Gauss-Seidel method converged and we got x equal to y equal to, that is 0.66129 and 0.87097. These are solutions. So flip the equations. So instead of this order, I'll just write in the reverse order. 4x plus 5y equal to 7. I'll write that first. And then 10x minus 3y equal to 4. The same equations. 10x minus 3y equal to 4. You know that the solution is same for both. But then what happens now? Now, if I ask in the exam, solve the following two equations using Gauss-Seidel method, you start applying Gauss-Seidel method without looking at the equations properly. So here I'll say x equal to 7 minus 5y divided by 4. Here y equal to, what is that? 4 minus 10x divided by minus 3. Right? 4 minus 10x divided by minus 3. So these are my equation A and equation B. Now if I go back to my code, so and then I'll just make a copy of it, save file as, then so initial solution for x is 1, initial solution for y is also 1. I'm just assuming that. And then let me do, okay, 15 iterations. And these two equations will change. 7 minus 5y by 4. 7 minus 5 into y divided by 4. And what is the next equation? 4 minus 10x divided by minus 3. 4 minus 10 into x divided by minus 3. That's it. So now if I run this, the question is will I be able to get the solution? So let's see. So you see all kinds of variety numbers are coming on picture, and if you look at the last one, minus 7.66 into e to the power of 7 and minus 2.55 into e to the power of 8. So these numbers are kind of diverging and you are getting some kind of wrong answers. You're starting with zero point 0.5, then 1.3, then negative, then positive, again negative number, then positive number, again negative number. So all kinds of wrong things are happening. The reason is, if I go back and if I write this in matrix form, so you will get 4, 5, 10 and minus 3. And then you get x, y, then you get 7 and 4. So here you see 4 is less than 5. In fact, not it's also not a problem if the magnitude is, like if it's a negative sign, but it's also okay, but the magnitude should be more. Similarly, 10 is more than 3. So therefore the diagonal is weak. So the diagonal has to be dominant. So then only this Gauss-Seidel method will converge and give a good this thing. So solution does not converge. Because diagonal is not dominant. All right. So what does it all mean for our power system problem? So let's get back to our challenge problem and then try to solve it. Excuse me. So let's go back to our problem, and then I'll just copy this problem once again. So I'm making a copy of the challenge problem here once again. So solving using Gauss-Seidel method. So when Gauss-Seidel method was invented, it was 1823 AD. At the time, the electrical engineering was practically non-existent. So all these power systems and all were not existent, but still they developed a mathematical tool, and today we are finding the application of mathematical tool in for our power system problem. So this easy one anyway, I don't care about this. So let's do this. So what was the equation that we had before? So I'll go up, I'll copy this equation. So I'll apply Gauss-Seidel method. So when you apply Gauss-Seidel method, so what I'll do is I'll keep this V2 on one side and then I just transfer everything to the other side. So what I'll get is minus V2 equal to this one, J 0.1 multiplied by 0.6 minus J 0.3 divided by V2 conjugate, and there is a minus sign. So let's make it plus and then put a minus sign here. That's it. So this is the equation, and then I'll simply do iterations on this. GS iterations. So for calculating V2, I need value of V2. So I assume some initial value of V2 and then solve it and then again I'll get V2, that I'll substitute here, again solve it, again I get V2, and so on, and then I'll be able to solve it. So let's go back to my MATLAB code. So I'll make a copy. All right, so let's do initial guess. So V2 equal to 1. So we know that the voltages are all close to 1 per unit. So that's the advantage of using per unit system, because you can actually get, so otherwise you don't know how many volts, is it 11 kV or is it 122 kV or whatever. But you can safely assume if we are solving the problem in 1 per unit, initial guess V2 is 1. So I have only one equation actually. So what is V2? Equal to minus of 0.1 I multiplied by 0.6 minus 0.3 I, and then finally divided by conjugate of V2. So this is the equation. That's it. And then I can display the value of V2. And then I'll be able to see whether V2 value is converging or not. So just check once again. Minus J.1 minus 0.1 I, okay. 0.6 minus J.3, okay. 0.6 minus J.3. And then this one, okay. So everything looks fine. So let me run this. So some problem. So let me just resolve the problem and come back. I'll just pause it for a while. All right, I just checked the problem. You know, it's a very basic problem. Actually, I forgot this one when I was coming from the here to here. So you see, from this to this, there will be minus one or something here. So this one I did not consider here. Actually, let me just rewrite this. I'll just make some place here. I'll remove this minus. So what I'll get is 1 minus V2. So this numerator I keep it as it is. So it's nothing but this into this. Then from this, if I want to get V2, then I'll get V2 equal to 1 minus this whole thing, J 0.1, 0.6 minus J 0.3 whole divided by V2 conjugate. So this is the actual correct equation. I forgot the one. Now again, strictly speaking, there is one more problem here that might be with the current direction. Let me just implement this and see what happens. So I'll just put 1 here. This is the same code that we had before. I'm just putting 1 here. Alright, so now here I'm getting 0.965188 and then this one. So this is the final value of V2. So I think this is correct. So why I'm able to say this is correct is, so from this, V2 equal to 0.965188 minus J 0.06. So I can tell, because first of all I can see the magnitude is less than 1 and the angle is also less than 0 degrees. So therefore that will confirm the direction of active and reactive powers. So let me calculate the absolute value. So absolute value of V2 and then angle of V2. This one I'll convert into 1 degrees. So 0.967 and then minus 3.55 degrees. So 0.967 angle minus 3.55 degrees. So this is the way we use per unit, we use the Gauss-Seidel method to solve our difficult problem. I don't know what method you tried to solve the second problem, but then this is how we are able to get it. So let's do one more problem so that it will become more better understanding of how to apply Gauss-Seidel method. So we'll do that in the next video.